So we basically end up with this y of s, and we would like to get the inverse so that we finish the problem. So the inverse of something like this, of course he's doing it for different n, by the way. So n at the problem, if you remember, the equation that we are solving is for n equals 0, 1, 2, 3. So because it's function of n, he would call the inverse basically L of n. This is a famous equation, okay, and the solution is Rodriguez formula. So that Rodriguez formula is basically it's basically the inverse of this guy. It's this is the Rodriguez formula for different n. So when n is 1, that's very easy to get, and basically when n is 0, when n is 0, just simply become the inverse become 1, because it will be 1 over s, so it's 1. But for different n, that is the inverse. Okay? L of n, it's e to power t factorial n, the differentiation of order n to t of n e minus t. So now the question is, in the midterm next week, if you have something like this, how do you get the inverse for it? Okay? How do you prove that he's basically giving you this and he said find the inverse? So how do you think about that? So here are the steps to think about it. So there wasn't see, it's Sn plus 1. It's like Sn plus 1. So you would actually think, well, first forget about the numerator. Let's think it's 1 over Sn plus 1. Just this. That's the first step. What if it was only this? Well, if it was only this, that's t to power n over factorial n. The factorial is here because it's in the t domain, remember? If we are getting the Laplace of t to power n, it's factorial n over Sn plus 1. So the inverse of 1 over Sn plus 1 is t to power n over factorial n. And then, so that's simply Sn plus 1. But you'll put s plus 1 and s minus 1. And then you tell yourself, what if it's only s plus 1? Why would you do that? Why would you think that I need to put s plus 1 and subtract? Because you want the form to be every s is s minus something. So you had s minus 1 over here, and there is no s here. So you would say, if only I can have s plus 1 and s minus 1, so that it can match this guy. So for s plus 1, what's the difference between 1 over s and 1 over s plus 1? That's simply a shift in the t domain. E to minus at translate into s minus a. So if it's e to minus t, then it becomes s plus a. Alright? And then what about the s to power n on top of it? Well, this must come from the nth differentiation, the differentiation of order of n. Remember, if you have the first differentiation, you get s times f of s. If you have the second derivative, you get s squared. If you got the n order differentiation, then you get s to power n. But there was also Sn minus 1 times the initial condition minus Sn minus 2 times the derivative at t equals 0, right? All those initial condition. Well, this is assuming basically that all the initial condition is 0, right? So all the small y of t is basically 0 initially. Okay, so that's why. And then Sn minus 1 and s minus 1. So it's the same function, but every s is shifted by s minus 1. That's another shift in the t domain. So that was the motivation that you would say, if only I have Sn minus 1 and Sn minus 1, right? S minus 1, S minus 1, then everything would be shifted in the t domain. So that proved the Rodriguez formula, right? This is basically exactly his formula, and it's coming from those steps. Okay, go back home, have a cup of coffee, and think about it. Why it's basically done that way. I think what's really hard is you start like this and you try to prove it, especially if you don't see the minus 1. I mean, those are easy. It's easy if you have the table. I mean, what's so hard about reading the table and get what is the inverse of Sn plus 1, or even s plus 1, the whole thing to power n plus 1? Those are easy, but what's hard is that you think that strategy. Basically, you start here and you can see the way forward, huh? And you are trying to basically assemble those components, right? You tell yourself, I need s squared, I will make a differentiation, I need s plus something, that will be the time shift. That's what's hard about that. And if you can actually figure this all by yourself, it will not be called the Rodriguez formula, it will be called the Roberts formula. Right? So what I'm trying to say, it's like the first time you come up with something like this, it's probably hard. Understanding it is pretty easy if you have the table. But coming up with the strategy, it takes a lot of time. Okay? Alright, so the division in the t domain is integration in the s domain. So multiplication in the t domain, it turned out to be differentiation, and division, it turned out to be integration. Right? So just in case you have a coefficient that's basically over t, not multiplied by t, well, you integrate there. That's it. So here are those rules that we went through, okay, including the convolution. I like it for, I show you in a second. The first shift, we did this today. Sorry, the t shift, not the s shift, or basically the second shifting theorem, right? So the first shifting theorem was basically that when you had e to power at, then become s minus a. The second shifting, if you have ut minus a, then it become e to minus as. Alright? And the multiplication and the division, it turned out to be differentiation and integration. Right? We'll leave this. And then all those table, right, with the functions. Questions? Alright.